Welcome back to Arxflix. Today, we're diving into a groundbreaking paper titled PowerInfer, Fast Large Language Models Serving with a Consumer-Grade GPU. This research tackles the challenge of efficiently running large language models, LLMs, on personal computers, PCs, equipped with consumer-grade GPUs. Imagine using powerful LLMs like Optwin 75 on your own PC. That's what PowerInfer makes possible. The problem is that LLMs are memory hungry. They require massive amounts of memory, often exceeding the capacity of even high-end GPUs. This figure shows the typical LLM inference process. It involves a prompt phase, where the model processes the initial input, and a generation phase, where the model generates tokens one by one. Each token generation requires accessing the entire model, making it memory-intensive. Existing solutions like model compression and offloading have limitations. Compression techniques reduce model size but still leave models too large for PCs. Offloading, which distributes the model between GPU and CPU, suffers from slow data transfers and limited CPU capabilities. PowerInfer's key insight is that LLM inference exhibits high locality. This means that only a small subset of neurons, called hot neurons, are consistently activated across different inputs. This figure shows the architecture of a transformer layer and how neurons are sparsely activated in the fully connected layers, FC and FC2. The green rows or columns represent activated neurons. PowerInf leverages this locality by preloading hot neurons onto the GPU for fast access, while cold neurons are computed on the CPU. This reduces GPU memory demands and data transfers. This figure shows the architecture of PowerInfer. It consists of an offline component that profiles the LLM and determines a neuron placement policy, and an online inference engine that executes the model based on this policy. The offline component analyzes the activation patterns of the LLM and categorizes neurons as hot or cold. The online engine then loads hot neurons onto the GPU and cold neurons onto the CPU. PowerInfer's inference engine is designed to be neuron-aware. It uses online predictors to identify activated neurons and only processes those, skipping inactive ones. This engine also utilizes neuron-aware, sparse operators that directly interact with individual neurons, eliminating the need for dense matrix conversions. PowerInf achieves impressive results. On a PC equipped with an NVIDIA RTX 4090 GPU, it achieves an average token generation rate of 13.20 tokens s, with a peak of 20.08 tokens s. This significantly outperforms Llama CPP by up to 11.69 times. This figure shows the speedup of PowerInfer compared to Llama CPP for various models and output lengths. PowerInfer consistently outperforms Llama CPP, especially for longer outputs. PowerInfer also demonstrates impressive performance with INT for quantization, achieving an average speedup of 5.01 times on a lower-end PC. This figure shows the speedup of PowerInfer compared to Llama CPP for various models and output lengths. PowerInfer consistently outperforms Llama CPP, especially for longer outputs. PowerInfer also demonstrates impressive performance with INT for quantization, achieving an average speedup of 5.01 times on a lower-end PC. PowerInfer is a game-changer for LLM inference on PCs. It leverages the locality of LLM inference to achieve significant performance gains without compromising accuracy. This research opens up new possibilities for running powerful LLMs on more accessible platforms, making them available to a wider audience. Thanks for watching Arxflix. Don't forget to like, subscribe, and share this video with your fellow AI enthusiasts. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.